Hack the planet! Hack the planet!
Shut up and get in.
Hey there, HackerFrogs. The music's a bit loud, so I'm going to be turning it down. Okay. Alright, so I am the Shy Hat, and we are HackerFrogs. We're going to be doing two different topics today, as per usual. So what we're going to be doing first is we're going to be taking a look at HackerFrogs After School Linux Basics with Pico CTF. This is part 3 of the 5-part series. So we're more than halfway through, but if you're a beginner, that's not a problem at all. You can feel free to jump into this session because we're going to be taking it easy and just building on the skills that we've been learning for the last couple of sessions. All right, and after we do Linux Basics Part 3 with HackerFrogs, which is a co-production with Black Girls Hack as well as Women's Society for Cyberjitsu, we're going to be working on some HackMyVm. So this is a platform where we can do some hacking against vulnerable virtual machines, VMs. So this is we're going to be working against this machine today. It's called Flower, but that's going to be in the second half of the stream. In the first half of the stream, we're going to be learning some Linux terminal basics, and that's going to be with Pico CTF. So let's get started. This is the third Intro to Linux OS Operations workshop, and in the previous workshop we learned about the following Linux commands. So let me just make sure that alright, so it looks like my audio is working, so let's get going. So in the last workshop we talked about the find command. The find command is used to search for files on the system. It can be used with many different arguments and flags to refine the search parameters. So just in case anybody is new to the Linux OS workshop today, we're going to be working extensively on some Pico CTF challenges. So Pico CTF is a platform where you can learn cybersecurity skills. If you don't have an account there and you want to participate in today's session, you can go ahead and make an account over at this website right here. I've provided it to everybody in the chat. But let's get going. And if you don't have an account yet, you can go ahead and make an account over on the website while we do our little review. So you've got a little bit of time to do that. So we learned about the find command. It can be used with different arguments and flags to refine search parameters and search for different files on the file system. So we also learned about the grep command that searches within the contents of files for specified strings. It's very commonly used to pick out specific words or phrases. So the find command and the grep command are used pretty commonly when you're working inside of the Linux terminal environment in order to find specific output or files that are on the system. We also talked about the mkdir command, sometimes called the makedir command, which is used to make directories. So you can create directories inside of your file system by using this command, and we often use it to create directories to work within when we're doing our challenges. So we also talked about the rm command. The rm command is used to remove or delete files or directories. We can also use it to delete directories, but we have to use a certain flag, a certain switch to do that. So for example, if we wanted to delete a directory called first find, which we did in the last session, we would do rm and then -r and then the name of the directory or file that we want to delete. Okay, so that was the rm command. So let's continue where we left off. So everybody, what we're going to be doing is we're going to be completing the What is a Netcat challenge over at Pico CTF. So I've got a document. Where is that document? It's over here. So I've got a document which has a bunch of the challenges that we're going to be completing today, as well as some YouTube walkthroughs, just in case you wanted to take a look at the way of solving the challenge outside of this class. So you can get to this document over at the following link that I'm providing in the chat. And we're going to be solving this challenge first. It is called What's a Netcat? So okay, so actually before we solve this, before we move over to this URL, what we're going to do is we're going to open up our Pico CTF web shell. So Pico CTF is a very convenient platform for learning cybersecurity because they provide us with a web shell, which is an environment where we can complete challenges. So if you want to open up the Pico CTF web shell, which is basically a Linux terminal where you can complete challenges in and you can interact with your own little space, you can click on, after you're logged into the Pico CTF website, you want to go to the practice page over here. So just click on practice up here in the gray bar. And then you're going to see, after you scroll down a little bit, you're going to see this button right here. It's labeled web shell. And what you need to do is you need to click on it. And that's going to open up the web shell terminal. So this is great. Unfortunately, we don't want to work within such a small space. We want a bigger space. So what we're going to do is we're going to click on this button right here. It looks like a box with an arrow pointing out, and it's labeled Pop-out Web Shell Terminal. So just click on that button, and then a new tab is going to appear inside of your web browser. And hopefully this opens up for us. So sometimes this putting the web shell in its own browser tab gets stuck. So we might have to try doing this a couple of times. So what I'm going to do is I'm going to close out this tab and I'm going to try again. So we're just going to click on the web shell button one more time. And then we're going to click on the pop-out web shell terminal button again. And then it seems like it doesn't work the first time, but it'll work the second time. Okay, so when you see that your web shell terminal is in its own browser tab over here, and it's nice and big, please type in the chat web shell up, smiley face. And then I'll know that you're at the same point as I am, and you're ready to start the challenge. Okay, so let's go back to the link for the challenge. It's going to be right over here. And I'm going to paste it in the chat for everybody to access. Okay, so just copy the link from the chat, and then go over to Pico CTF. Okay, web shell up. Great to see you. Great to see you, Nico Lee. Thank you, and welcome to the stream. I hope you're here to learn some new Linux skills. All right, so all you need to do is paste in the address for the challenge and then hit enter. And then you should see this page right here. So this description for the challenge says, what's a netcat? The description of the challenge says, using netcat, otherwise known as NC, is going to be pretty important. Can you connect to this server over here at this port over here and get the flag? All right, so this challenge wants us to connect to a certain port using the netcat program in order to get the flag. But what is netcat? So I'm going to explain what netcat is. And before that, let's go over to our web shell. So the web shell, if you log in and you don't do anything for a little bit, it's going to disconnect you. But all you need to do is hit the enter key to reconnect to it. Okay. All right, so inside of the web shell terminal, you should be able to do all of your standard Linux commands. And let me explain what netcat is before we solve the challenge. Okay. All right, so we're talking about the netcat command. So netcat is a versatile computer networking program, and one common use of netcat with Pico CTF challenges is to connect to non-standard services on remote servers. So remember that services exist on different computers that are on the internet. And when we talk about remote servers, we're talking about a computer that is that has a service on it that is remote, meaning that it's not our own computer. So netcat can be used to connect us to those remote servers on specific networking ports. So the syntax for using netcat to connect to a remote server on a specific port is as follows. So netcat is usually shortened down to NC for netcat, and then we do the IP address or domain, and then we supply a port number. For example, we've got NC and then jupiter.challenges.picoctf.org, which is the server that we're going to be connecting to on some port number. So this port number might be different for you, but I think the port number is the same for everybody in this challenge. So what we're going to do is we're going to issue this command to use netcat to connect to this challenge server. So in the what is a netcat challenge description, what we're going to do is we're going to highlight this right here. So everything from Jupiter until the end of the port number over here, we're going to highlight that. We're going to copy that, and then we're going to go over to our web shell. So if the web shell has disconnected, go ahead and hit enter to reconnect to it, and then we're going to paste in what we just copied. So you can use the Control-Shift-V keyboard shortcut, or you can right-click and then select Paste. So you might as well try to use the keyboard shortcut while we're here. So regularly on any other kind of program, you do Control-C and Control-V for copy and paste. But when you're working inside of a Linux environment, you have to do Shift as well. So it'd be Control-Shift-C and Control-Shift-V. So in order to do the keyboard shortcut to paste, you would do Control and Shift and V, and then that's going to paste in what you have on your clipboard. Okay? So we have to adjust this command a little bit in order to have it go off. So over here, we're going to delete everything except for the server name and the port number. And then in front of the command over here, we're going to put the netcat command. So that's going to be nc and then space. So this is netcat at this server right here on this port. So when we execute this command, it's going to connect to the server, and then we're going to receive this output over here. So you're on your way to becoming the netcat master, and then it gives you a flag. So it's Pico CTF netcat mastery, and then some hexadecimal output over here. So all you need to do is you need to highlight this flag string, and then you need to copy it. And then you need to go back to the challenge description. And at the challenge description, there's a box at the bottom over here. This is called the flag submission field. Just click on that and then paste in your flag, and then click on submit flag, and that will complete the challenge. All right, so I hope everybody successfully completed that challenge. If you managed to complete it, please type in the chat netcat, and then if you want, you can put in some cat emotes. But we're going to move on to our next challenge. So let me talk about the Pico CTF plumbing challenge. So this is going to introduce a new concept that we haven't really explored before, and we're going to be talking about command piping. And command piping is actually a very important part of working inside of a Linux environment because it lets you chain commands together. But before we get ahead of ourselves, let's move over to the challenge environment. So the challenge is going to be at this URL right here. And I will paste that in the chat. All right, so it looks like Nico has finished the challenge. Thank you very much. I'm glad to see it. I'm glad to see it. Okay, so the new challenge is going to be called plumbing. So we're going to go over to our Pico CTF page, and we're going to paste in the URL. And we see here that the challenge is called plumbing. And it says, sometimes you need to handle process data outside of a file. Can you find a way to keep the output from this program and search for the flag? Connect to jupiter.challenges.picoctf.org on this port over here. So this is another challenge where we're going to be using netcat in order to connect to a remote server. So all you need to do is copy this server and port combination right here, and then go over to your web shell. And inside your web shell, you should see that your terminal is stuck right here. Anytime your terminal becomes stuck because the program is becoming unresponsive, you can use the Control-C keyboard shortcut in order to exit from the program, basically, or exit from the command. So it's Control-C, and you should see this symbol right here, and then you should see your prompt over here, meaning that you regain control of the terminal. Okay. And remember, anytime you've got some clutter over here that you don't want to see anymore, you can always issue the clear command in order to delete the stuff on your screen and go back up to the top of the terminal. So if you remember, we just copied a server and port combination from the challenge description. So what we're going to do is we're going to paste in that port. So we can use the keyboard shortcut Control-Shift-V, and that's going to paste in the server and the port number. And what we're going to do is we're going to put NC for netcat in front of it, because we're going to be connecting to this server on this port using netcat. So the thing is, if you were to run this command, you're going to see all of this output right here. So I don't think this is a flag, this is not a flag, and there's just a lot of it over here. So what we want to do is we want to pick out the flag value from all of this output over here. Does anybody know what all of the Pico CTF flags begin with? What is the word that all of the Pico CTF flags begin with? You know? If you know, type it in chat, okay? All right, so let's go back. And while we're waiting for some answers from chat, I'm going to go over to the presentation and we're going to talk about command piping. So we're talking about command piping. In Linux, command piping is the process of passing the output of one command into the input of a second command. So, all right, Nico says it's Pico. That's correct. So Pico is the beginning of all of the Pico CTF flags. So what we want to do is we want to pick that out of the output that we get when we run our netcat command over here. So what we want to do is we want to run this netcat command, and then we want to run grep on it in order to pick out a specific string, which is Pico. And to do that, we're going to use this pipe right here. So the pipe character is actually the shifted version of the backslash on your keyboard. And it's not very often used if you're not doing programming or Linux or anything like that. But just keep in mind that it's the shifted version of the backslash on the keyboard. Spartang799, thank you very much for subscribing or for following on Twitch. You are now a HackerFrog. Okay, so this is a very useful feature because it allows commands to be chained together to achieve a lot of flexible output. So what we're going to do is this. This is what's happening when we're running this command with the pipe. Number one, so netcat, this is the first command. Then we have to supply the pipe, which is number two over here, and the second command, grep. So whatever is the output from this command is going to be piped into the grep command. So the grep command is going to use the output of the first command as its input. So this runs the netcat command, and the output of the command is passed to the grep command, which searches for the output for the Pico string. So let's do this over at the web shell. So back at the web shell, you can actually access previous commands that you've typed in the terminal by using the up and down arrows. So on your keyboard, you've got your up, down, left, and right arrow keys. If you push up and down inside of your terminal, you should be able to recall previous commands that you've run. So all you need to do is you need to hit the up and down arrow keys until you see your previous netcat command. So it's going to be the shorter netcat command, which is 4427 over here. And what we're going to do is we're going to pipe this. So it's going to be space, and then we're going to use the pipe character, which is the shifted backslash, and then another space, and then we're going to run the grep command. Remember that the grep command is going to pull out specific pieces of text or patterns that you provide to it. So the pattern we're looking for is Pico, because all of the flags in Pico CTF start with the word Pico. So when we run this command, then we get exactly this output right here. So it's only going to return any lines with the word Pico. And remember that this previous command had a lot of output, but among that output was this flag right here. So in order to finish the challenge, all we need to do is copy the flag. So you can copy it and then go back to your Pico CTF challenge. Down at the bottom here, in the flag submission field, paste in the flag, and then click on Submit Flag, and then we are finished. All right. So if you managed to finish that challenge, please type in the chat, I used the pipe for plumbing. Smiley face. All right, so next we're going to be learning another concept with another challenge. So over here, we're going to be learning a new concept, and this concept is going to be about some encoding. So encoding is something that we do a lot inside of computer networking, and we're going to be talking about the most common, a very common type of encoding called base 64, and we're going to be, this is not the name of the challenge, but anyways, the challenge is called bases. And it's going to be at this address here. And just look at the chat, and you should be able to see the URL link for the bases challenge. So let's go over to Pico CTF, and we're going to paste in the URL right here. Okay. So let's see. Nico has used the pipe for plumbing. Great. That's great. Okay. So inside of the bases challenge here, the description says, what does this? What does this mean? I think it has something to do with bases. So if you've heard of different encoding schemes before, such as base64, let us know in the chat. Otherwise, let's learn a little bit about this before we solve the challenge, okay? So over here, so we're going to be talking about the base64 command inside of Linux. But base64 isn't just in Linux. Base64 is all over the internet. And what the base64 command does is that it encodes and decodes data according to the base64 codec. So it is often used to convert data for transmission across computer networks. So if you see here, the 64 characters that are used as symbols in base64 are these ones over here. So there's the order that they're in. So it's all of the alphabet over here. So all of the capital letters, all of the lowercase letters, all of the numbers, and a plus and a slash. So these are the characters in the base64 encoding scheme. So the characters used in base64 encoding are shown here. Note that all base64 encoded strings must consist of a number of characters that is divisible by 4. So we're going to demonstrate this in a little bit, but base64 as an encoding scheme takes some bytes of data and it turns them into another form of data, which is called a base64 string. So in cases where an encoded string is not divisible by 4, the encoding process will pad out the string with equal symbols until the string is divisible by 4. So this over here is an example of turning some information into a base64 encoded string. So we can use this command right here called echo in order to provide output to be piped into the base64 command. So if we give the base64 codec the pattern password, so this string right here, it'll turn it into this string right here. And you'll notice that the string right here has a number of characters divisible by 4, because that's how the codec works. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this string is actually only 11 characters long, but because the base64 codec needs the number of characters divisible by 4, it'll provide an extra equal sign over here in order to make sure that it's something divisible by 4. Okay, so we're going to be using the base64 command in order to solve this challenge. So what are the different parts of the command we're going to be doing? We're going to be using the echo command to give the base64 command the input for the base64 string right over here. So this is the string that is in the challenge over here. We're going to provide that as input, or output rather, through the echo command, and then we're going to pipe it into the base64 command in decode mode. So decode mode for the base64 command is activated by using the -D over here. So we've got our echo, we've got our input, we have our pipe, we have our base64 command, and then we have the decode flag over here. So we're using this echo command, but what is the echo command? So the echo command is used to create output equal to whatever is supplied to it. So on its own, if you do the command echo 1234, then the terminal is just going to give you 1234 in return. That by itself doesn't seem very exciting, but it also can be used to supply input to another command through command piping. So I can demonstrate over at the web shell over here. Let's just get out of here. So if we do echo 1, 2, 3, 4 tests, whatever, it's just going to repeat that back to us. But if we were to do echo 1, 2, 3, 4 test, and we were to pipe it into base 64, this command right here, then it's going to give us the base 64 version of 1, 2, 3, 4 test, which is this right here. If we were to take this right here and echo that, and then pipe it into base 64 decode, like this, then we would get the original string back, 1, 2, 3, 4 tests. Okay, so now that we understand what's going on, let's solve the challenge. So over at PicoCTF, we've got this string right here. What does this mean? We're going to find out. What we need to do is highlight this, copy it, then go over to the web shell. In the web shell, we're going to supply the echo command. We're going to paste in the string that we provided. We're going to pipe it into base 64 -d for decode, and then we're going to issue the command with the enter key. So what is returned over here is this. So this is the flag right here. The problem is that this is not the complete flag, because the complete PicoCTF flag has whatever is inside the flag encased in curly braces, and it also has the flag prefix. So this right here, whoops, we're going to copy this up until the number 5 over here. So copy it, and then paste it into your terminal. We're going to edit this a little bit. So we're going to type in PicoCTF, and then we're going to add the curly braces to the beginning and the end of the contents over here. And then this is a complete flag. So it's going to be Pico in lowercase, CTF in uppercase, opening curly brace, learn the ropes, closing curly brace. Copy this. Then go over to the PicoCTF challenge page. In the challenge page, paste in the complete flag, and then click on Submit Flag, and then we're finished. All right, so if you managed to finish that challenge, please type in the chat, base 64 is based. Smiley face. Okay, if you need any explanation, any further explanation or any questions about any of the concepts we've been going through in today's session, please let us know in the chat, because I don't want anybody left behind, and if there are any questions you might have, I'm happy to answer them if I can. So just to finish off our spiel on the echo command, for example, this is an example of the echo command used to supply the input to the base 64 command. We've got, Shandaria Richards, hello, nice to see you. And I'm glad to see that you're participating in the challenges. Okay, so if we do echo base 64 encode test, and we can put this between some single quotes, and then pipe it into the base 64 command, then we're going to see a base 64 encoded string. So you might ask why we put. So let me just demonstrate this. So over at the web shell, we can do echo, and then between these single quotes. So the reason we're using these single quotes with the echo command in this case is because if we include any special characters inside of what we want to echo out, it might interfere with the terminal if we don't use these single quotes. For example, if I do base 64 test like this, and then I try to pipe it into base64, this works. But if I tried to put some other special characters in here, maybe I'm going to put like a minus sign and an exclamation point at the end. Oh, it still works. But just trust me when I say that when you put special characters into your echo command, you should probably put it between some single quotes or double quotes, just in case the terminal interprets it in a weird way. So this is supplied and given to the base64 command, and it lets it encode it into a base64 string. Okay? All right, so let's do our final challenge of the day. And the final challenge of the day is going to be called... Oh. So next, sorry, I've got a couple more things to explain. So we're going to be talking about output redirection. So this doesn't necessarily have to do with any specific challenge, but it's good to know about output redirection. This is another feature in the Linux terminal that can be used to direct the output of commands and write that output to a file. So the previous echo command was an example of this. So over here, the echo command can be used to create files containing the echo content by combining it with output redirection. For example, we've got this, echo test, and then the greater than symbol, output.txt. So this command is going to create a file called output.txt with the text content test. So we can go over to our web shell and demonstrate this. So we can just echo and then the word test, and then we use the greater than symbol over here. This is output redirection. And we're going to redirect this into a file called example.txt. So when we run this command, the echo was used as to provide some output, and the output was redirected into a file called example.txt. If you use ls to take a look at what's in the directory now, there's this file called example.txt over here. And if you were to read the file by using the cat command, then you should see that example.txt, its contents are this word right here, test. That's because we created it with this command over here. So let me explain one more concept with output redirection over here. So we've got this command right here, this find command. Remember, we can use find to locate specific files. So the above command here takes the output of a file, the output of the find command. So this is the find command. We're looking for files with a name equal to star.jpg. Star in this case means that it could be anything, but as long as it ends with .jpg over here. This is anything.jpg basically, and it redirects the output of this command, the find command, into a file called jpeg_file_list.txt. This is a useful technique that can be used to save the output of commands for later use. Okay, so let's demonstrate this. So, oh, this is not what I wanted to do. I wanted to go to the web shell. Okay, so what we're going to do is we're going to do a find command, and actually, okay, so if we have example.txt and readme.txt over here, we can do a find command in the current directory and then search it by name, and it's star, which basically stands for anything, .txt. So anything.txt, we're going to redirect that into a file called txt_file_list.txt. So if we run this command, I did something. Past must precede expression. Okay, so I think I've done my syntax a little bit wonky over here. Okay, let's do another. Let's do something else as an example then. Okay, so the output of who am I, which is a command that retrieves the current username, in my case is the shyhot-pico.ctf. So what I'm going to do here is I'm going to do who am I, and I'm going to redirect the output of who am I into username.txt. So who am I, the output of that is going to be output redirected into username.txt. So we run this, and then we've got here username.txt. We created a file, and the contents of the username.txt file is going to be the output of this command, who am I. So if we do cat on username.txt, it's going to have the content equal to the output of the who am I command. Amanda Ferguson says the slash. Oh, right. Okay, yeah. You are right, Amanda Ferguson. So in my find command, I forgot to do // to refer to the current directory over here. So I get Linux syntax mixed up all the time as well. Oh, it didn't work in this case either. That's weird. But anyways, I'll investigate this a little later. What we're going to do is we're going to do the final challenge for today. Now that we know how to do output redirection in Linux, so just if you've been doing the following along with me, you probably want to eliminate these files over here. So you can just use the rm command in order to delete the files. And remember, you can use the tab autocomplete in order to autocomplete the names of files in the current directory. That's very useful. So we want to keep our home directory in the Pico CTF web shell as clean as possible because we don't like clutter. And if we can minimize that, that's great. Okay. So let's do the repetitions challenge. So let's practice the concepts we've been learning in this session with the Pico CTF repetitions challenge. So we've got our last challenge of the day, and it's going to be over here. Please look at the chat, and the link should be there. So after you've copied the link, go ahead and go over to your Pico CTF website, paste in the link in your web browser, and you should see this challenge right here. And the description, the name of the challenge is called repetitions. So the description says, can you make sense of this file? Download the file here. Okay, so this is the first challenge of the day that actually has a file associated with it. That's exciting. So if you remember how to create directories and how to download files, then go ahead and try to do that. But if you don't remember, that's okay too. The first thing we want to do is we want to get the link for the word here, and we want to select copy link. Then over at our web shell, we're going to create a directory to work inside of. And so we're going to use the make directory command. And in this case, the name of the challenge is repetitions. So issue that command and then enter that directory. So after we're in the repetitions directory, we're going to download the file using wget. So it's wget and then space, and then you can use the keyboard shortcut Control-Shift-V in order to paste in the address. So After you hit enter, you should have downloaded the flag. You should see this kind of output. And if you do ls inside of your directory, you should see that the encoded flag is here, enc_flag. I hit the wrong keyboard shortcut. Okay. So enc_flag. So normally, when you use the base64 command, it's actually looking for a file. So when you do base64 by itself, it's looking for a file. For example, if I echo out test 1, 2, 3, 4, and then I redirect that into a file called test.txt, we're going to see that test.txt is in this directory, and it has the contents test 1, 2, 3, 4. So if we do base64 and we run it on test.txt, the name of this file, then it's going to take the contents of test.txt and it's going to encode them using the base64 encoding scheme. So if we run this, then we get this over here. This is the base64 version of test 1, 2, 3, 4. So does anybody know how we would, so if this is the pattern, how would we decode the contents of enc flag right over here? So this file right here, what is the command we should do to decode enc_flag using base64, this command? So I'll give you a few seconds to give your theories if you want to type those into chat. Otherwise, I'll be explaining it in a few moments. Okay, so base64 usually runs on files, and we have this file called enc_flag. What we want to do, because we want to decode this, so first of all, so the contents of this file is this. So this is a very long base64 encoded string. And the way we can identify this is because this string over here is made up of capital letters, lowercase letters, numbers, and the biggest tell of all that this is a base64 encoded string is the presence of these equal signs at the end over here. So remember that the equal signs over here are known as padding, and they're used to pad out the length of a base64 encoded string in the case that it's a number that's not divisible by 4. So these padding characters are used to pad out the length of the string so that it's a number of characters divisible by 4. So we want to decode this into something that is readable by humans, and we can do that. Mustafa A says, bro, it's base64. That is true. So what we're going to do is we're going to decode the contents of this file by running base64 on this file, but we're going to give the decode flag over here. So it's base64 enc_flag -d, and that's going to decode the flag. So the problem is that when we give this output over here, that this new output over here is also a base64 encoded string. So this looks kind of like this over here. So because the name of the challenge is called repetitions, What do you think we need to do in order to solve this challenge? Does anybody have a guess what we need to do in order to keep on decoding this string over here? So I'll give you a hint. It's something that we explored earlier in today's lesson. So I'll give you a moment or two to guess if what is the method of solving this challenge. Otherwise, I'll be explaining it in just a little bit. So just to let everybody know, so on this channel, there's some fun little video redeems that you can run by typing in the exclamation point and then the word redeem and then the space and then the name of the redeem video that you want to see on the stream. For example, this one over here is some Stellar Jays. SJ is the command, and these are my favorite little birds that come to my bird feeder. Okay, so the way we finish this challenge, oh, it went off twice. So the way we finish this challenge is we need to repeat this base64 decoding process. So the way we're going to repeat this is by using command piping. So what we need to do is we need to run the previous command, except that we're going to use the pipe and we're going to give another base64 decode command. So the result of this first decode command is going to be passed over to the second decode command. So it's base64 and then pipe and then base64 decode again. So if we were to run this, we get a different base64 encoded string. So if you see the difference between this string, which is the original one, and after we decode it once more, it's a slightly shorter one, but it's also base64. And this one, which has been decoded twice, has a smaller base64 string. So what we need to do is keep on doing this. So we're currently decoding twice, but we can decode 3 times. So we just need to provide another pipe and then do base64 decode again. And we see from the output that we have an even shorter string in this case. So it went from 3 lines to 2 lines. So let's go back up to the top with the clear command. So even when we decoded 3 times, we still got a base64 string. So we're going to decode once more for a total of 4 decode cycles. So decode, 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 decode. When we run this, we get an even shorter base64 encoded string. So we're going to decode it 5 times. So we've got 4. We're going to add another pipe base64 decode, and then we get a single line of base64 encoded strings. We're going to decode it a 6th time, and then we get the flag. So after decoding a total number of 1, 2, 3, 4, 5, 6 times, decoding using base64, we get this flag right here, which is called Pico CTF base64 nested decoding over here. All we need to do to finish the challenge then is to copy the flag, then go over to the challenge page, and then in the repetitions challenge description, paste in the flag, and then click on Submit Flag, and then the challenge is finished. Okay. All right, so if you managed to successfully complete the challenge, please type in the chat base 64 is repeated. Smiley face. All right. So to finish, what we should do is we should probably do some cleanup. So over at the web shell, we're going to go back to the directory just above this one. So you can do cd ... in order to go up one level in the file tree. If you do ls after this, you should see the repetitions directory here. We're going to delete the directory because we're finished with the challenge. So it's going to be rm-r and then the name of the directory, which is repetitions. So just do that, and then we should see that our directory, it only has the readme.txt file in here. All right, so if you have any questions about anything that we did during the sessions today, or if you have any questions in general about Linux or anything else, go ahead and type it in the chat. Otherwise, what we're going to do is we're going to go into the review for today's lesson. So let's review the Linux commands we learned in this workshop. So we learned about the netcat command. So netcat is a versatile computer networking program, and one common use of netcat with Pico CTF challenges, anyways, is to connect to non-standard services on remote servers. So we had some challenges that were located on remote servers, and we used the netcat program to access those challenges on specific networking ports. We talked about command piping. So command piping is the process of passing the output of one command into the input of the second command via use of the Linux pipe character. We also talked about the base64 command. It encodes and decodes data according to the base64 format. It's often used to convert data for transmission across computer networks. So a lot of the times when we transfer files from one computer to another across a network, we have to transform the data that is the contents of the file, because if we transfer files as is without transforming the data, there's possibility that the file contents could be corrupted in transit, and that's not what we want to see. So that's why encoding schemes like base64 exist. We also talked about the echo command. It's used to create output equal to whatever is supplied to it. It can be used to supply input to another command through command piping. And we talked about output redirection. So it's a feature in Linux that can be used to direct the output of commands and write that output to a file. So what's next? In the next Linux OS operations workshop, we'll keep learning about Linux commands through the Pico CTF platform. Remember, we've got a full schedule for the Pico CTF, or the HackerFrogs After School program. This is called Batch 1, which consists of the courses Linux, Python, and web app hacking, over at the HackerFrogs Reddit, which can be located at this link that I've provided in the chat. So today is October 4th. We just did our file management session. And on October 7th, which is Monday, we're going to be doing session 4, which is file permissions. This is a bit small. Let's make this a little bit bigger. But yeah, so if you enjoyed today's session, then I'd be very happy to know which organization you're coming from. So if you're coming from Black Girls Hack, please type BGH smiley face in the chat. And if you're coming from Women's Society of Cyberjitsu, please type WSC smiley face in the chat. I love knowing where the students are coming from, so I can report back to those organizations about who and how many students are attending these sessions. Thank you very much. But today's HackerFrogs After School Linux workshop, Linux session is now done. And what we're going to be doing is we're going to be shifting into our second topic for today's live stream, which is some hacking. So what we're going to be doing is we're going to be... All right, so Nico is coming from BGH. Great to see, great to see. I've been working with with BGH, Black Girls Hack, for the last 10 months or so, since the beginning of 2024, and it's been a great experience being able to work with so many great community members over at Black Girls Hack. I've also been working with Women's Society for Cyberjitsu, but for a shorter period of time, but that organization is also great. So if you want to participate in the second part of today's stream, you're going to have to have access to a Kali Linux machine, because we're going to be hacking against the HackMyVm.eu website over here. And the way those challenges work is that you download virtual machines and run them on your virtual machine network to hack against. So today's challenge is called Flower over here, and you can find it over at this link over here, which I will provide to everybody in the chat. So if you want to participate, you can download. If you want to participate, you can download the virtual machine from that link that I provided in the chat. But otherwise, for this portion of the stream, I'm going to turn on some music, and let's see. So let me get my music from YouTube. Hopefully, I'm just doing a little experiment and I'm going to try to play some music from YouTube. Hopefully, I don't get copyright struck for using this playlist. So this playlist is from a game that I like to play. It's called Baba Is You. Oh. Why? Hold on. I just need to do a little bit of stuff off the screen.
And we're back. The team is looking down the barrel of 455 on the game.
Okay, so
Jones is taking the ball and running with it. She's asking Grammarly to write the first draft of an email.
What a play. Grammarly is an AI writing partner that helps you make your point.
She's got a clear shot and it's good.
okay, so over here we've got a bunch of different.
Download Grammarly for free. This is your idea of a perfect.
We've got a bunch of different devices on the network over here. This is my network in particular. And I think the machine that we're looking for is located at this IP address right here. So it's 10.2. Hold on. Okay, so right now I'm going to hook up the music to the stream. So just a moment. Okay. And I'm connecting the music now. Okay, so you should be able to hear the music. If you can't hear the music, let me know. But if you can hear the music, let me know if the music is too loud or too soft, because I certainly don't want it to be too loud and drown out my voice. In fact, I can make this a little less loud. Okay, so 10.0.2.93. So let's go over to another tab, and we can try pinging that machine. It's not ping. 10.0.2.93. Okay, so it seems that we have some sort of connection to this machine. So this machine is actually running on my virtual machine network. So I'm just going to grab. So the machine is working over here inside of my virtual machine network. You should see that there's not very much over here. It's just a login screen, but the machine is running on my network. And what machine is this? It's the Flower machine at this that is the challenge from the HackMyVm.eu website. Okay, so with that being said, let's try running an Nmap scan on it. So Nmap is a very common tool inside of cybersecurity, and it's used to determine what ports are open on a specific server. So I'll provide the IP address of the machine that we want to access, and we're going to run that. And we've discovered port 80 is open on this machine over here. So port 80 is the port for HTTP, which is the insecure version of web pages. So what we're going to do is we're going to navigate to this web page on this IP address over here. So the IP address is local only to me, so if you were to access this yourself, you wouldn't be able to. So over here, I'm just gonna... Okay, so this looks like... So the number... So the name of this challenge over here is called Flower. So it looks like we're at the right place, because there are a bunch of flowers on this webpage. So count petals. Choose a flower to count petals. So we've got this drop-down menu over here. So we've got lily. Well, we've got a bunch of different ones over here. So let's try lily, and we click submit. It says 3 petals. I don't know whether or not this is accurate for the number of. So we've got buttercup.
There are a few moments where we send you off.
Oh. Okay, so it looks like I've got ads on my YouTube over here. So what I'm going to do is I'm going to use a different source for music, and it's going to be this right here. Okay, hopefully this music doesn't have ads, because I do not enjoy having ads. So let's make that a little... Okay. All right, so let's continue. So it says here that there are 5 petals on this flower. So I'm not completely sure how this web app works, but it looks like there's a button and there's a drop-down menu. Let's take a look at the HTTP source for this page right here. So it looks like we're sending... It looks like we're sending these flower names over here with a specific value, and this might be done as, so it looks like it's done as a HTTP post method. So we could try emulating this in order to figure out what's going on with the app. Another couple of things we could try doing is we could try doing some other scans on this website. So on this website, we could try looking for the robots.txt file. And hey, Shandaria has finished the challenge. Base 64 is repeated. Great to see, great to see. All right, and what we're going to do is we're going to look and see if on this website we can see a robots.txt file. So there's no robots.txt file found on this server. Another thing that we could do is we could go over to... So I'm going to go to my temporary directory. So while I'm working on these machines, I like to stay inside the temporary directory, just so I don't clutter up my my file system. So just so you know, I'm working inside of a Kali Linux machine over here, and Kali Linux is a very common Linux OS distribution that that people who do cybersecurity education like to use, because it has a bunch of cool cybersecurity tools that are already pre-packaged into it. So one thing we could do when we're scanning against targets that have HTTP, which is usually on port 80, is we can run a Nikto scan on it. And Nikto is a web app vulnerability scanner, and it might be able to find some vulnerabilities for us. So we can just run this command over here, and it's just going to keep on. It's just going to keep running, and it's going to see if it can find some different vulnerabilities for us. So immediately it was able to tell us the version of web server that is being run over here, and that's Apache. So Apache is one version of web server software, and it also gives us a version number and the OS operating system that it could be running under, which is called Debian Linux over here. So we also have this this manual over here, and we've got this directory exists on the website. So we could manually go to enumerate this, but another thing we can do, because we know that this server has a website, is that we could run a gobuster command in order to do some directory busting. So directory busting is a web app enumeration technique where we try to determine what valid directory names there are on the system. So when we run gobuster, it's going to try a bunch of different directory names according to a word list, and the word list is this list over here, directory list 2.3 medium.txt. This is a very large list of different directory names, and we're going to try all of them against this website right here. So I just need to make sure that I have the right website, the right IP address plugged in. So we're going to run this over here, and it's probably going to give us a lot. It's going to test a lot of different directory names. So we're going to run this, and immediately it finds this manual directory over here. So we can actually try going to this directory inside of our web browser. So in our web browser, we're just going to go over to manual. And this leads to this this Apache server page over here. So I guess you could see we can definitely tell that this web server is running Apache because it's got some documentation web pages installed over here. And I guess it wasn't able to find anything else. So what I'm going to do is I'm going to try running this again, but this time I'm going to look for file extensions. So what file extensions am I going to look for? I'm going to look for TXT. I'm going to look for HTML files. I'm going to look for PHP files. And we're just going to start there. And we're going to try to look for some different files inside of the website. So we can run this. Okay, so we see that there is an index.php web page. So this app is running PHP. So PHP is a specific language that is common to web applications, web pages, and there are specific vulnerabilities for PHP that we could take advantage of if we manage to get to that step. So let's so what we're going to do is we're going to go back. We've got our manual for Apache over here. Let's go back to the landing page, which is index.php. So we've got our flower website right here, and we could choose anything. Okay, so it gives us 34 petals. All right. I guess this is a website where we count petals. So what we need to do is we need to figure out if there's some sort of security flaw inside of the website over here. And the way we would do that is we want to capture the traffic that's going back and forth between the website and the web browser. So what we're going to do is we're going to start up Burp Suite. So Burp Suite is a very common tool used in web application testing. And the free version of Burp Suite is available on Kali Linux. And we're just going to start this up. And after we activate Burp Suite, after we start it up, then we're going to be able to capture traffic and inspect it. So after we go over to Burp Suite, I'm going to activate the Burp Suite browser, which we can do over here. And if you have any questions about any of the tools that we're using, I understand that, especially if you're a beginner and that this stuff might not make too much sense. But if you have questions, and if you have specific questions about the tools that we're using or the techniques we're using, please let us know, because I'm happy to answer any questions you might have about this. Okay, so I'm going to just copy this this web page address, and then in Burp Suite's browser, we're going to paste in the address and navigate over here. So this is the same thing. The reason I'm using Burp Suite's browser as opposed to my my regular web browser over here is that Burp Suite's browser is connected to Burp Suite, and any requests that happen inside of Burp Suite's browser are going to be recorded. So we can just do a couple of submissions and see what kind of traffic appears. So after we've done some submissions over at the website, I'm going to minimize my Burp Suite browser, and then I'm going to go over to Burp Suite and look at the HTTP history. So this is a bit hard to see, but we can see these. There's a list of different requests that happened when we access these web pages. So, for example, this over here was the request, and this is the response to the request after it was sent. So what I'm going to do is I'm going to put this in the Burp Suite repeater, which is a tool inside of Burp Suite where we can repeat different web requests. And I'm going to send this to the repeater. Then I'm going to go over to the repeater, and I think I can make my output a little bit bigger. Can I make it bigger? Maybe not. But this is the post request over here. So when we're sending information to, let's see if I can make this. Okay, so we're going to send this post request over here, and we're going to take a look at the response. So we get exactly what is advertised over here, this response right here, except this is the text version, and the text version is this text version is going to give you a lot more information than what is shown on the web browser. So I think we might be able to take advantage of some sort of SQL injection if we supply a random value to pedals over here. So if I just send this, then this is going to be blank. Okay. So first of all, I would like to make my interface a little bit bigger so that everybody can see. Let's see. I think over in Burp Suite, there's some options. So for the repeater, how can I make this bigger? Okay, I'm just going to Google this real quick. So Burp Suite. Increase font size. Okay, so display user options, display section of burp. Okay, so user options, display section of burp. Is there a display section? Where is it? Display? Okay. Okay. So there's a font size over here that I can change. So these can be changed under user interface and HTTP message display. So we've got user interface. I'm going to increase the size of this font over here. So let's try making it 20. Oh, this is bigger. Okay. All right. So and is there anything else we can change over here? HTTP message display. So let me try. HTTP message display. Let's change the font size over here. So we're going to change the font. We're going to make this 20 sized font as well. Okay, so that is much bigger. Actually, we can make it even bigger than this. So let's make it 28. Oh, that's really big. Maybe it should be a little smaller. Okay, so just in the interest of making things more readable for everybody who's watching at home. Okay, so we've got our HTTP response over here. We've got our HTTP requests over here. And what we can do is we can play around with the what we're sending to the server. So previously, we've got our option names. Let's try in the render view. So the render view is going to show us what it would look like inside of the web browser over here. But the render view is not especially. So I'm going to try a basic SQL injection string over here. And I'm going to let's try sending a double quote and see if that changes anything. So if we're to send a double quote, okay, it doesn't necessarily send us anything unusual. So what we're going to do is we're going to do a union select to see if we can get some sort of output from the application over here. So I'm going to union. Actually, wait. Maybe we should send something legitimate. So, okay, so this is a legitimate body request. So petals equals this over here, and it shows us 3 petals. All right. So we're going to tack on a single quote to the end of this and see if anything appears. So it still says 3 petals. Let's try a double quote. Okay. So let's try a union select now. And we're just going to send the union select here. And then nothing appears. So union select, maybe we're going to send it null. We're just going to send it null and see if okay, so null, nothing appears, and then maybe we'll try 2 columns. So this is an iterative kind of attack where we're trying to send the database a number of columns equal to the original query, and if it's successful, we could potentially get some extra information out of the database. So we're going to send this null null. Maybe we'll send 3 null null null. Okay, so could be that this isn't what we need to do right now, but let's take a look at some other avenues for exploitation here. So I'm going to get out of here, and I'm going to get out of minimize our burp suite. Okay, so we've got the manual. We've got index.php. Okay. So we've got our manual. So in our regular web browser over here, we're going to go over to the manual. And this over here, is this actually going to search Google when we start typing stuff in? So look for Apache, do a Google search. This is going to send us to google.com. Okay, great. That's good to know. All right, so we've got our flowers website over here that is choosing to count petals. That's great. Let's get the source code over here. What I'm going to do is I'm going to ask ChatGPT if it has any suggestions for how we can attack this web app. So this code for the website is quite short, so I should be able to supply this. Actually, so I'm going to copy this all, and then I'm going to go over to ChatGPT, and in ChatGPT I'm going to ask the following question. So the question is, this is a web app from a CTF challenge. Based on this code, what are some potential ways to test the security of this web page? And then we paste in the code, and then we see what kind of answers ChatGPT could. Okay, to test security of the web app, here are a few approaches based on the provided HTML code. Base64 decoding and parameter tampering. The values of the flowers in the dropdown are base64 encoded. These values, such as this and that, can be decoded to see their underlying content. Decoding these values might reveal sensitive information, patterns, or hints for further exploitation. So decode the values from base64. So this is relevant to what we were doing in the previous section of the stream. We're talking about base64. You can use an online tool or the terminal command to do this. After decoding, try changing these values to see how the server responds. For example, modify the value before submitting the form. Okay. So let's test this one over here. And over on our terminal, let's paste in this command. So it's going to echo this, and it's going to decode it according to the base64 codec. So 1 plus 2. 1 plus 2, okay. That's interesting. So this might output something like 1 plus 2, modified to something like 100 plus 200, encode it back to base64, and submit to see if the server processes it differently. So we can also do parameter fuzzing. Since the form sends a post request, you can fuzz the petals parameter to see if it leads to unexpected behavior. So use tools such as Burp Suite or manually modify the request by intercepting the post request and try different inputs for the petals parameter. Submit long strings. Okay, we could try SQL injection, command injection, format string vulnerabilities. Check for input validation. Investigate if the server properly validates or sanitizes input. since the drop-down values are encoded and used in a back-end process, possibly mathematical operations, improper validation can lead to logical flaws. So we could try sending unexpected inputs such as special characters, numerical overflows, empty values, or null values. So exploring hidden endpoints. The form action points to the root of the web app. There may be hidden or interesting endpoints that the form doesn't directly show. Try exploring additional directories or files like admin, login, debug, or config. Okay, so there's also... Okay, so we've got a bunch of different avenues we could explore for this web app over here. So we've got our... So one thing that was suggested that we could try is we could try encoding something into base64 and providing it to the web app. So for example, if we were to echo 1 plus 1 instead of 1 plus 2 and encode it using base64, we get this over here. So we could try supplying this as our body when we're sending the post request and see if it provides some kind of different output. So over here, we've got our web app and we've got our petals key. The value we're going to put in is this over here. Okay, so after we send this, let's see if it provides some sort of different. It says 2 petals. It says 2 petals. So the previous output gave us 3 petals, but this gives us 2 petals. I wonder if I can increase the size of this inside of, maybe I can't. Okay. All right. So let's echo something else, maybe 1 plus 3. Is this going to give us the result 4? Because it looks like the number of, let me try this. Okay, so copy this, and then we're going to supply this base64 encoded string. Paste this in, send it. 4 petals. Okay, so whatever is sent in here is going to give us a number. So whatever mathematical equation we send to the app, it's going to interpret the base64 encoded string over here, and it's going to decode it, and then it's going to give us the result of the mathematical operation. So for example, if we do if we just give it like a bunch of 9s, so if we give it 999 and then give this to the app, it should give us the result 999. So let's test that theory. Okay, and then we're going to send this. So this is correct. It gives us 999 petals. So if there's, let me take a look at the web page code once more. So over here, so the action is this. So I guess the question is, why does ChatGPT think that this is referring to the web app base or root directory? So let me ask ChatGPT about this. Why do you think that the web app post request is acting on the web app root directory, which is this. Okay, so you're right to ask for clarification. I assume that the form's action / might be interpreted as the root directory of the web app, but it's important to explain that assumption in more detail. Okay? In the HTML code provided, the form element includes the following line: action / method post ID flow sub. The action attribute indicates the URL to which the form data will be sent when the form is submitted. So the / typically represents the root path of the web application. Therefore, when the form is submitted, the post request will be sent to the root of the web app. Why is this significant? Okay, root path in web app. Many applications use the root path for the home page or as the main entry point. If the web app is designed in this way, submitting the form to this could trigger a backend process testing for vulnerabilities. Because the form is posting to the root, you would focus your tests on the server's handling of post requests to this endpoint. It could also suggest that other logic for handling for the request resides at this, making it an important endpoint to inspect. Okay, so we could try adjusting this. We could try changing the directory from / to something else. So if we were to try going back to our burp suite and post. So the question here is the action. Can we post it to something else? So instead of /, could we try posting it to ... and see if it gives us something different? So this gives us absolutely nothing. So nothing is returned in response. So if we take a look at the at this, it says it's a bad request. So we can't send it here. Let's see if we can send it to just ... and send this. So this is also a bad request. So we need to send it to just this /. Okay, so that means, so if we're assuming that that this whatever that we're sending to the server is being decoded from base 64, and then some sort of mathematical, and then it's just taking whatever number is there and presenting it on the web page, we could probably take advantage of that. So let's try encoding something else. So over at our terminal, let's try echoing 999, and then we could try breaking out of the command. If this is being run with the Linux command, then we could try breaking out of it and asking what user account is being used with this "who am I" right here, preceded by the semicolon. So we can try encoding this, and we can try sending this to the server and seeing if it actually runs our code over here. So it runs our command rather. So let's go back, and here we're going to paste in this and then send the request. So it still only replies with the number over here. So the thing is that we sent this number, and then we sent "who am I," but it ignored everything after this over here. So this part of the command was ignored, but it did take this as the input for whatever it was going to, whatever mathematical thing it did to. I guess it just echoes this, and I guess it checks it checks if this is a number. Does it check if it's a number? What if we just encode this and send it? So let's copy that and then go back to Burp Suite. Paste it in and let's send that. So it basically echoes. It echoes. So it looks like whatever we send to it in base64, it echoes this out and then it adds the words petals to it. So let's try sending something else. So let's try sending this. Actually, for this, what we're going to do is we're going to use something online. So because the terminal could start messing with this. So let's go over here, and we're going to go to base64 encode. Encode. So we can encode into base64 online. So I'm going to get the home variable and copy that. Then over at Burp Suite, we're going to see if we can actually get the application to give us some variables inside of its system. So this didn't give us anything. Okay. So I suspect that the application is using a Linux echo command. So if we were to use our terminal, for example, and we did echo 1 plus 2, then how do we get echo to do math? Hold on. Let me look this up really quick. So let's just Linux math with echo command. How to do math on the command line. So let's just look for echo. Sure, accept this. Okay, so hold on. Let me ask ChatGPT. Using the Linux echo command, how could we do simple math like 1 plus 1? Okay, the echo command in Linux is primarily used to display text, but it cannot perform arithmetic operations on its own. However, you can use arithmetic expansion in Bash to evaluate simple math expressions. This is how you can do it. Echo, okay, so it's variable, I guess, of 1 plus 1. So this is the expression. So this is a Bash arithmetic expansion and allows you to perform integer arithmetic. The echo command then prints the result of the evaluated expression. Okay, So let's make this font a little bit bigger so that the people who are watching can better read. Back at the terminal, we're going to paste in this this expression right here. It should give us the number 2. So that gives the number 2. But if we were to instead replace this with this text, who am I, then it's going to give us 0. So maybe it's not giving us, it's not using echo. Maybe it's giving something, it's doing something else. So what command could do math, but could also print out text? All right, so I'm going to ask this question. So I suspect the web app I'm looking at is using some sort of Linux command to perform math and output it to the app. But the app can also return strings if strings are provided to it. What is the possible command being used? It sounds like the web app you're working with may be using the Linux XPR command or BC, a basic calculator utility to perform math equations, to perform math operations. Both tools allow arithmetic and can handle strings under certain conditions. The EXPR command is a simple utility in Linux for evaluating expressions. It can handle both arithmetic operations and string operations. Okay. So let's do a little bit of experimentation. So we could go over to our terminal and do some experimentation with this. So EXPR 1 plus 1, this is going to give us 2, right? No, it doesn't give us 2. That's is it because I didn't put in a space? EXPR 1 plus 1. This gives us 2. Okay. I wonder why it doesn't work when we stick it all together. Strange. Okay, and if we were to give this a string instead, it prints out the string. Okay, so this is a possible contender for what's going on in this web app. So it could be using the EXPR command, but it could also be using the BC command, the basic calculator. So it's a more advanced utility that can perform arithmetic operations, including floating point math, but it allows for some string processing when used in scripting. So the XPR command, the implication is that it can't handle floating point numbers. So we could try getting a floating point number. So echo 1.1 and then pipe that into base 64. And we can see if it actually handles this correctly. So go over to our burp suite, provide this as the thing to be evaluated. Okay, so it actually does handle floating point numbers. So we can actually wait. So that actually wasn't math. So let's try doing it as math instead. So maybe one plus 0.5. Or maybe 1.0 plus 0.5. Okay, and we can see if it actually does the math in here. So if it does the math, that means that we're not dealing with the expr command, because it's implied that the expr command doesn't do floating point numbers. But that could be, I mean, that seems very limiting. But let's see if this gives us some different output. Okay, so paste this in, send it off. 1.5 petals, so it does work. It is doing the math. Okay. So if you provide non-numeric values, expr will handle them as strings. For example, if you try to evaluate expr abc plus 1, the output will return an error, but it will return abc if only a string is provided. abc plus 1. Okay. Let's copy this and see if... So we're going to echo this out into base 64. It's going to be this. And let's see if this errors out the web app. Paste this in, send it off. It ignored the string. Okay, so because this ignored the string, let's go over when we sent abc plus 1. To the app, it only output the 1 to the web app. Which program could we be dealing with? The behavior you're describing suggests that the web app could be using the awk command. Okay, so awk is a powerful text processing utility in Linux that can perform both string and numeric operations. When presented with a mixture of string and numbers, awk tends to ignore the string part in the mathematical expressions, similar to what you're observing in the web app. So echo abc plus 1 awk print something something. This will output 1 because awk tries to evaluate the arithmetic operation and treats any non-numeric parts as 0 or ignores them in the calculation. So when awk encounters a string and a number in the mathematical expression, it will strip away the string and process the numeric part. The behavior aligns with what you're seeing when sending abc plus 1, resulting in the output of just 1. So another candidate could be the bc command, but this is less likely because bc is more strict and would typically throw an error when encountering non-numeric input, rather than just outputting the numeric part. Okay, so what other tests could we send to the app to determine if it's using the awk command? Okay, division by 0. Test how the app handles a division by 0. In awk, this generally results in an error message. So expected behavior, if it's using awk, it should return an error message similar to division by 0 or inf. String to number conversion. Test how it handles inputs where strings are mixed with numbers. awk will treat strings as 0 in arithmetic operations. So we could try this over here and see if it results in an error or if it just doesn't return anything at all. So over here, we're going to echo this thing out. Okay, and then we're going to provide this to the web app through burp. Send that. Inf. So that indicates that we're dealing with the awk command, right? Because expected behavior, if it's using awk, it should return an error message similar to division by 0 or inf. Okay. So let's try sending this over here. So we're going to send one more test to the application to determine whether or not it's using awk as the command being used. So we're going to echo out, whoops. We're going to echo out this, and then we're going to send this to the app. If the app is using awk, then it should only output the number 5. So I'm going to copy that, go back to our burp suite, paste in this, send it, and it returns 5. Okay, so I think we're fairly certain that the web application is using awk in order to do its calculations. So that means if the app okay, so could we potentially send it the help flag to output help information? Okay, if the web app is using awk in the backend, sending it the -- help flag could potentially output help information, but this depends on how the app is processing input. If the app is directly passing user input into the awk command without sufficient sanitization, you might be able to exploit that to trigger a help message or error output. Okay, so -- help. Let's try that out. What we would be doing, we would do this, but we would do -- help, which is this. Okay, and then we send this to the app. Send it off. This didn't return anything, so it could be an error message, could be something else. Or if the app is expecting some sort of mathematical expression or string, you might need to craft it in a way that it still passes this argument, such as 1 -- help. If the input is passed directly to awk, this could result in the awk help message being displayed. Okay, so let's try this. Back at the terminal, oh, we did help plus 5. That wasn't what we wanted. We wanted this to just be help. Okay. That was a user error on my part. Sorry about that. Okay. So back at Burp Suite, let's send it this. Okay, that didn't give us anything. Let's do what was suggested by ChatGPT, which is this. Let's try sending it this input. Okay. This right here. Send that. This results in an error message, probably. Input validation. The web app might be sanitizing input before passing it an awk, preventing flags like --help from being executed. Potential for command injection. If the app isn't sanitizing input well, this could open the door for more dangerous command injection attacks, not just viewing the help message. Besides help, you could try other common awk flags such as V to define variables, tactec version to check for version information. Okay, maybe we could check for version information by doing this, tactec version. Okay, let's try this. If this doesn't work, we could try doubling up on the dashes. But then again, this could be interpreted as these dashes could also be interpreted as the minus sign, in which case that's no good. But let's just try this one first and see if. So let's send this. Okay, so that doesn't do anything, but let's actually ask ChatGPT if the app or the awk program is interpreting the dashes and the -- help flag as minus signs. How could we get around that? Use the double dash. The double dash is commonly used in Unix-like systems to indicate the end of options. Everything after double dash is treated as arguments and not as flags. If awk is interpreting -- help as subtraction, using double dash might allow the commands to interpret -- help as an option. If the input is preceded by awk, is processed by awk, try this. This tells awk to stop interpreting flags and treat -- help as an argument. Okay, so let's try that. So -- help -- version. Let's do double dash and then -- version to see if this gets a different result. Okay, then back at Burp Suite. Paste that stuff in, send it off. Okay, this also results in some sort of error message. Let's try this. And then back over here. Send it. Oh, okay. So this is interpreted as a literal string. Okay. Okay, escape the dash character. So we could try escaping the dash character so it's not interpreted as part of a flag. You could try slash, let's try this one as well. So over here, dash dash version or dash dash help. Let's try using the backslash escape character. Whoops, what is this? This. Backslash escape character. And we'll just try one backslash escape character to see if this is sufficient. If it's not, we'll try the second backslash escape character. Paste this in, send it off. Okay. Looks like we're going to try the second backslash escape character. Then try this. Burp Suite. Paste it in. Okay. This is a no-go. So we suspect that that the program being run is awk. We need to what is another example? What is more input that we could test to prove that the command being used by the app is awk? Okay, string and numeric addition behavior, so we tried that. Modulus operation. So awk supports modulus operations. This is not as common in other basic math handling commands such as xper and bc. Testing the modulus operator could give you a clear indication. Okay, so if this is the case, then the output should be 1. So let's try this. Back at the console, paste in this. The expected output is 1. Let's see if that is what is output. Paste that in. So the modulus operation did go through. So that's another point. That's another point in awk's favor. Rather that the program being used is awk. So let's try one more just to. In awk, you can concatenate two strings by placing them next to each other with no operator in between. This is a behavior unique to awk. So foo and then bar, the expected behavior if awk is being used, the output should be foo bar. Handling empty strings. Test how the web app handles empty strings. In awk, empty strings are treated as 0 in arithmetic operations. So foo bar, let's try creating this using basic C4. Okay, and then if the app is running awk, then it should return as foobar without the space. Paste it in, send it off. It doesn't return anything. It doesn't return anything. Let's just send this and see if it actually sends anything. Paste that in. Doesn't send anything either. So that's it's less likely that it's running awk then. Concatenation of strings, handling empty strings, built-in functions test. So awk supports a variety of built-in functions that can be useful for testing. Here's a few examples. So the length string is a function that returns the length of a string. So expected behavior, if it's using awk, then the output should be 5. So let's try this. Okay, paste it in. Let's put this between single quotes. So just to make sure this is what we think it is, I'm going to go over to base64 decode. I'm going to paste this in, and then I'm going to decode it here. Length hello. Okay, so this is what we want. Okay, let's go back to Burp Suite and paste this into Burp Suite. So this should give us a number if it's running awk. This didn't give us anything. So that means we should try this, the square root of 16. So the expected behavior, if it's awk, should be 4. Let's go back. Whoops, we need to create a base64 encoded string. And we're going to encode this. Okay, then back at Burp Suite. So if this is running awk, it should be, the answer should be 4. Okay, so I'm going to try one more test, just one more test to see if what we're dealing with is the awk command. String to number conversion test. Automatically converts strings to numbers when performing arithmetic operations. Test this conversion behavior. So if it's awk, then the output should be 1, 2, 3, 4. Okay. Let's encode this. And then it looks like my music is stopped. Okay, so I'm pretty confident. I'm pretty confident that this is awk that we're dealing with. Let me try playing my music one more time. So let me grab, where's my music? So we've got our Baba Is You OST soundtrack. We're going to try it out in another browser tab. And hopefully this one doesn't have ads. Okay. So hopefully that's okay, hopefully this music isn't too loud. If it's too loud, let us know in the chat. So okay, I'm fairly confident that that this program is using awk, the Linux command, in order to run the app over here. So what we need to do is we need to figure out how to do command injection. All right, so we are fairly confident that the Linux command being used by the app is the awk command. How can we leverage this to perform OS command injection? All right, so awk's system function. Awk has a built-in system function that allows it to execute OS commands. If you can inject this system function through unsanitized input, you may be able to run arbitrary commands. Command chaining. If awk is executed in a shell or as part of a broader script, you may be able to use typical shell meta characters such as semicolon, double ampersand, double pipe to break out and execute commands directly. Injecting awk's system function. The system function in awk allows executing shell commands. If you can inject a payload containing this function, you may be able to execute arbitrary commands. System ID. This input tries to execute ID, which prints the user's identity, using system function after completing a simple arithmetic operation. Okay, so let's try this. So we're going to copy this, we're going to encode it using base64, and then we're going to feed it to the app. And let's see if any output actually appears. We have OS command injection. We have OS command injection. So let's celebrate with some Hack the Planet, everybody.
Hack the planet! Hack the planet!
Okay. All right. So we have OS command injection. We managed to get the ID of this current user. So theoretically, that means we could be able to. All right. So the problem here is that we have to encode everything before we do anything. So what I'm going to do is I'm just going to get an easy ls command in order to see what's in the what is in this web directory. So where are we? Okay, so let's run the ls command using Burp Suite over here. Okay, so we've got the flower.jpg, the index.php, run.sh, run.sh, and pedals. Pedals? Is pedals a directory? If it's a directory, then we could access it from the web over here. So whoops. So pedals does not exist. So this might be a directory. What I should have done is I should have done ls-la to get some better output out of this. Okay, so let's go back and do the same thing again. Okay, so let's see this in the pretty mode. Okay, so we've got, what is this? We've got run.sh. Let's see if I can... Run.sh pedals. Run.sh. Index.php. Flower.jpg. Okay. What is this run.sh script over here? And how is it different from run.sh pedals? Okay, so let's read this file, run.sh, just to get a feel for what is going on with that script. So let's do cat run.sh. So back at Burp Suite, paste it in. Send it. PHPS pedals. So it's running PHP script. You know what? Okay. So the this web server is running PHP, so we could probably inject a PHP reverse shell in order to get access to the server. So what we're going to do is we're going to get a PHP reverse shell file. So we can probably do it over at PHP reverse shell. And is this the one I like to use? PHP reverse shell.php. Okay, so this looks like something we can use. So we're going to go over to the raw, and we're going to copy all of this. Okay, copy all this, and then we're going to create a reverse shell.php file on our shell. I'm not in the right directory. Let's go into the right directory. It's the TMP directory. Okay, so PHP reverse shell.php, and let's paste in the contents over here. What I need to do before I write this is I need to find out what my attacker machine IP is. So my attacker machine IP is 10.0222. Okay, so over here I need to change my IP to 10.0222, and the port I usually like to use 443 because it's the HTTPS port. Okay, so I'm going to save that, and then I'm going to set up a reverse shell, so a netcat listener to catch the reverse shell. So I'm going to put that on port 443 on my Kali system. And then from this directory, I'm going to serve. I'm going to serve this file right here on a Python. What was it? http.server. Whoops. Oh, I have to. It's a module -m. Okay, and I'm gonna. I guess I'll do it on port 80. Sure. Okay. So I've got a HTTP server on port 80, which serves this this directory's files. So I could probably force the web application to download this file right here, probably by using wget. And so let's craft this. So I'm going to make a new tab. Actually, in this tab, I'm just going to get out of here and go into my temp directory. TMP. So the name of the file is this. We're going to do wget, and then it's going to be HTTP, and then the 0222. This is my attacker machine IP address. We're going to download this file right here. So this should allow us to upload the file to the victim machine. So we're going to do this. Copy it. And then over at the base64 encoding site over here, we're going to paste in this thing. Okay, and then we're going to encode that, which is this thing over here. Copy that. Then over at Burp Suite, we're going to paste in this as the body for the web app. Post that, send that. It went okay. We didn't see any output, but let's take a look at our reverse shell listener. Okay, so the reverse shell listener shouldn't be able to see anything because it was only downloading it. So it was accessed. It was accessed from the victim machine over here, which means that we can navigate to this page inside the web app in order to activate the reverse shell. So what we would do is go over to our web browser and paste in the address. We can prepend 10.0.293. It says the requested URL was not found on the server. That's unusual. Okay, so what we need to do... Oh, no. This is working. So it's still loading. So we should be able to see our web shell. Yeah, okay, we're in. All right, so everybody put on your best hacker voice, because we're in. Okay, so let's celebrate. Let's celebrate with a little video redeem. And let's do Go to Hack from South Park.
Mr. Hat, may I please be excused from class?
Well, Kyle,
Yes.
you hear me? You go to
Hack.
You go to
Hack.
You
Have a great day.
I hope everybody's having a great day. Okay, so we're in. What directory are we in? We're in the top level directory. Okay, so there are no terminal variables set. Okay, so let's go over to the home directory, and then there's a user named Rose. Interesting. Let's go into Rose's directory. There's a user.txt flag over here. I'm going to cat that out for my own. Oh, I can't read that file. Permission denied. Okay. So there's also a diary directory. So that there's a plant book directory. So something tells me that the solution to this might be to go over to plant book. Plant book is a file. Plant book is a file that is owned by Rose, but we don't know what Rose's password is. So we can go into the diary directory, and we see that there's this diary.py file. So let's take a look at what's inside. So import pickle, November 28th, I found a blue viola. December 1st, I lost my blue viola. P open pickle. What the heck is this? All right, let me diary.pickle. Let me ask ChatGPT if it can interpret this. It's Glime says it's hide the pickle game. It's hide the pickle game. Wow. Yeah, that's what can you make of this Python code? Something is being hidden. It might be a pickle. Let's see if ChatGPT can give us some interesting insights. It's Glime. Welcome to the stream. Nice to see you here. Okay. So the Python code snippet demonstrates the use of the pickle module to serialize a dictionary object and save it to a binary file. Here's a breakdown of what the code does. The pickle module is used for serializing and deserializing Python objects, allowing you to convert them into a byte stream, which can be saved to a file or transmitted over a network. Okay, creating a directory. Creating a dictionary. Here, a dictionary named diary is created with 2 entries. Each key is a date, and the corresponding value is the string representing the diary entry. Opening a file for writing. The code opens or creates a file named diary.pickle in binary write mode. This file, It's Glime says, PC fried like 2 weeks ago. Just got my new one put together today. I think I forgot how to use a PC. Lol. I'm sad to hear about your PC getting fried, but hopefully the PC that you just built is going to give you some better results. And nice to see you. Nice to see you here. Nice to see you. All right, so just for reference, we're working on the Flower machine over at HackMyVm.eu. If anybody else wants to take a look at it, it can be located at this URL right here. But let's see. So the pickle.dump function is used to serialize the diary dictionary and write it to the file P. This means that the diary is converted into a byte stream that can be stored in the file. Implicitly closing the file is not explicitly closed in the code. Example of loading the pickle data. To retrieve the data back from the file, you can use the following code. Loaded diary equals pickle.load p, print loaded diary. The diary opens the diary.pickle file in binary read mode and unpickles the data and prints the dictionary. Okay. What is the name of the file created by this script? The file created by the script is named diary.pickle. This file is used to store the serialized dictionary diary in a binary format. Diary.pickle. Diary.pickle. Okay, so let's try looking for this file. So find in the entire file system name equals diary.pickle, and then put everything else in dev null and run that as a job. I don't know if that actually ran or not. Find / name diary.pickle to dev null. Okay, so I'm not sure why this didn't go off. But okay, what else is in this directory? So there's this diary.py file, okay. Plant book, bash rc, profile. Let's go into the... Okay, so we've got our reverse shell, we've got our run flower.jpg, index.php, PHP reverse shell. Let's see what is being run on the system. Okay, I don't see anything super unusual here. So no other directories to look in here. I guess we can look at the index.php. Yeah, this doesn't. This isn't anything we didn't know about. Okay, so let's take a look and see if there are weird permissions on the etc password file. So it's read-only, that's normal. Let's see if there's anything weird in the shadow file. The shadow file is also read-only, but not for any old person. Okay. What are some other directories we could start looking in? So we could start looking in the opt directory to see if there's any optional files in here. We do sudo-l. Oh, what? What is this? Wait. www.data may run the following commands on Flower. As rows, we can run with no password Python 3, and we can run it with diary.py. Okay, so we can run diary.py with rows. So we could probably use that to get a shell as rows. So let's inspect the permissions on that file. So /home /rows /diary /diary.py. So we only have read permissions. We only have read permissions on this file. Okay. Just because I'm feeling a bit lazy, I'm just going to ask ChatGPT. If we have without actually, no, I'm not gonna ask this question yet. Okay, back at the terminal. Let's just go over to okay, so we're gonna run Python 3, and we're gonna run diary.py. Actually, wait, we have to do this as sudo. So sudo u rows Python 3 diary.py. No TTY present and no ask pass program specified. Oh, okay. Let's improve our shell a little bit before we do this. Python 3 -c. It's going to be import pty.spawn bin bash. Okay, so that improves our shell a little bit. So maybe we can use sudo now. I don't know the password. Wait, why is it asking me for a password? It shouldn't be asking me for a password. because as rows, no password, we can run this. Maybe I need to use the exact file path. This one right here. Okay, paste that in. Unknown user. Unknown user? Wait. Unknown user. I think my syntax is wrong. Okay, so how do we use sudo to run a file in the context of another user? Sudo u target user command. Sudo u target user command. Yeah, I don't see anything wrong with my syntax. Let's check it again. So sudo u rows. Oh, I forgot to. No, wait, I did. So no, I did not. Okay, silly me, silly me. I didn't. Okay, copy that, paste that, run the thing. Okay, so we ran the diary, and now there's this diary.pickle file. Okay, so we created the pickle file. Diary.pickle. And we created using the this diary.py file. So something tells me that we're supposed to use some aspect of the pickle module to get privilege escalation. So let's cat the diary.py file again. Diary, okay, December, I found a blue viola, I lost my blue viola. Okay. Diary, pickle.dump. Okay, so let's ask for an answer from ChatGPT. It might be able to give us some good answers here. So we are able to run the aforementioned scripts as the rows user on the web server, on the server, by using the sudo -u command. How can we leverage this script to gain a shell as the rows user? If you have the ability to edit the script.sh, you should be able to modify it to include a command that spawns a shell. Let's see what else. So if the script itself allows for command injection or execution, you could attempt to invoke a shell directly when running the script. For example, if the script allows for command injection or execution, you could attempt to invoke a shell directly when running the script. For example, this thing and then bin bash. I don't think this will work. But you know what? I could always try. Okay, so we're running this command, and then as soon as this command ends, we run bin bash. So copy this, paste that in, and the command bin bash. Who am I? I'm still www data. Okay, so that was not the way. Create a new script. If you can create a new script that you can run with sudo, you can create a script named getShell. You can give it execute permissions, and you can run it with this. I don't have write permissions in this directory, do I? So you know what? I managed to successfully create a directory, to create a file inside this directory. So I have write permissions in this directory. So that means that I can create a new Python script that just gives me a shell. Okay? That's really interesting. So if you can create a new script, we can run it with sudo. You can create a script named getShell, but this is a Python script. Use sudo to directly invoke a shell. No. Okay, let's how can we write a Python script that gives us a Linux shell? Okay, import subprocess, import OS, function to create the shell, spawn shell, subprocess called bin bash, then run the shell. All right, this looks good. Copy this, and then let's I don't think I can use nano. diary.py. Unable to create the directory. Okay. Okay, so I can't. You know what? I could probably add on to diary.py. So right now, diary.py has all this stuff in here, but I can slowly include more stuff into diary.py. So I'm going to do this line by line. This is a bit tedious. We're going to add this to diary.py. Permission denied. Permission denied? I thought I had write permissions here. Oh, I don't have write permissions for diary.py. I don't have write permissions for diary.py. Okay. So we can write things in this directory. We just can't write diary.py. Okay, let's go back. If sudo is configured correctly, you might be able to invoke a shell directly as the row's user. Really? I don't think that's the way it works. Yeah, we need a password. Okay, let's grab the so this is the command, the command that we can do with sudo-l. Okay, so how can we leverage this to create okay. Hold on. Okay, so let's ask this question. We have access to this exact command. How can we use this for privilege escalation? If the script uses pickle, eval, or other insecure methods of handling user input, it could be vulnerable to arbitrary code execution. What? Pickle can be used for arbitrary code execution? Okay, well, let's if the diary.py contains something like this, input, enter your diary entry. You could execute this, and when prompted for input, you could do this. This would create a reverse shell, okay? So the script we have access to uses the pickle module. The code is this. And then given that the diary.py script uses the pickle module, this opens up several potential avenues for privilege escalation through unpickling attacks. Here's how you can leverage this vulnerability. Under scanning the pickle vulnerability, the pickle module in Python can serialize and deserialize Python objects, however is inherently insecure because unpickling data can execute arbitrary code if the serialized data is controlled by an attacker. Steps to exploit the vulnerability. Create a malicious payload. You can create a malicious Python object that, when unpickled, executes arbitrary commands or code. Here's how you can craft such a payload. This. Deliver the malicious payload. Once you have the malicious payload.pickle file, you need to make the diary.py script. We need to make the diary.py script, where is it? Use this file instead of the original diary.pickle. Unpickling the malicious payload. Diary.pickle. If you have control over how the diary.pickle file is read, or can inject this payload into the script, you can create a situation where it reads and unpickles your malicious payload instead. For example, if you can modify diary.py to read from your malicious... Okay, we can't modify the diary.pickle script. We cannot modify the diary.py script. But we can write to the directory where the diary.py script is located. Since you cannot modify the diary.py script but can write to the same directory, you can still leverage the pickle vulnerability by creating a malicious payload and naming it diary.pickle. Here's how to proceed. When the Python script, write a Python script that creates a malicious pickle file. This file will execute arbitrary code when unpickled. Wait. Here's an example of how to create that payload that spawns a shell. So import pickle, import OS, class exploit, okay. Create the payload, okay. Write the payload to the correct location. Make sure you save the diary.pickle file in the same directory as the diary.py script. If you're executing this code from a different location, you must make sure to specify the correct path. Execute the original command. Once the diary.pickle file is created, you can use the command you have access to. If diary.py attempts to load diary.pickle when it runs, as indicated by the code you provided earlier, it will unpickle the malicious payload, executing the command specified in the reduce method of exploit class. Okay, so what this is trying to indicate to me that we have to create a file called diary.pickle. Okay, so can we create... So we've got diary.pickle. So diary.pickle is also... Diary.pickle was created, so we can't necessarily... You know what? There's probably an easier way to do this. If we have write access to the directory where the diary.py file is located, couldn't we create a malicious pickle.py file which would be run when the diary.py file in the same directory as the diary.py file, which will be run when the diary.py script is executed. Okay, so if you have write access to the directory where diary.py is located, you can create a malicious Python script. Let's call it pickle.py, and that will be executed when the diary.py script runs. This approach takes advantage of how Python imports modules, allowing you to leverage the pickle module to execute arbitrary code. Here's how you do it. Steps to create the malicious payload using pickle.py. Create a malicious script. Write a pickle.py file that includes code to execute a shell or any other command you desire. OK. Place pickle.py in the same directory. Make sure to save pickle.py in the same directory as diary.py. That way, when diary.py is executed, it can inadvertently import pickle.py. Modify the environment to ensure that it imports. If diary.py does not explicitly import your pickle.py file, ensure that it is executed in a context where pickle.py was imported. You could potentially set an environment variable or modify the Python path, but the easiest method is to rely on naming conventions. For instance, you might name your malicious file in the same way that it gets imported or executed. If diary.py uses import pickle and doesn't define its own pickle module, your custom pickle.py would shadow the built-in pickle module during execution, and then execute the original command. Okay. So let's create a file called pickle.py. Okay, so I don't have terminal access, so I guess I'm gonna have to do this the hard way. The hard way is grabbing each one of these lines one by one. Grab this line and then echo it, and then put it in pickle.py. Okay, and then we do that again for all the other lines. So import OS and import sys, all this stuff. So this is a bit of a pain. The next line is import sys. And then the next line is class exploit. You know what? Let's ask if we can do this in... Can we write the malicious pickle.py script in as few lines as possible? Okay, so this looks like a much shorter script. Okay, so let's go over to echo this. Let's use double quotes since all the other things are single quotes. Pickle.py. Cat pickle.py. Okay. Okay. So let's run our command now. So our command is that we can do through sudo is this one right here. So let's run the command. I wonder why this didn't go through. Pickle.dump. Oh, you know what? We need to rewrite the malicious script so that it doesn't use the pickle module. This is much simpler. This is much simpler. Okay, let's run this. And we pickle.py. That's much simpler. Okay. Okay, so let's run that command now. This is... Oh geez, let me grab the command again. This is the command. Okay. Okay, so we run the command. And now we're rows. We've done our privilege escalation. Okay, so now that we're rows, we can go into Rose's home directory, and we can cat out user.txt. Okay, HMV roses are red. Great. Copy that. Okay, so what are we going to do? I'm going to note the flag in one of my note files. Okay, and you know what? I really need to get going, but if I'm able to find the privilege escalation technique very, very quickly, then I might be able to finish this off tonight. But let's just check this plant book file, the .plant book. Or is this a directory? Oh, okay. cat.plant book. Okay, it's a... It's a shell script file. Hello, write the name of the flower that you found. Echo nice flower submitted on date. So the plant book, I don't know if this helps us. But okay, so now that there were rows, okay, so I'm gonna stick my flag in here, and we're gonna try to finish this box next time. But once again, everybody, please have a great weekend. We're gonna be back on Monday, and so next time we're streaming is going to be for October 7th, and we're going to be doing Linux OS Operations Session 4, and we're going to be taking a look at file permissions. And we're probably going to be finishing off this machine. Well, we're going to try to finish off this machine. But in the meantime, let's take a look and see if there are any great InfoSec streamers that are streaming right now, and we can raid into them. So we've got Cyber Info HQ, who's streaming on Twitch. Let's see what they're doing right now. Okay, so it looks like they're working on something. They're doing a cybersecurity question and answer right now. So we're going to raid into them. I would really appreciate it if anybody on Twitch were to join in on the raid, because we love to support our community. Please tell the Cyber Info HQ that that you're from the Shy Hat raid, and tell them that. And I hope you I hope you enjoyed that person's stream. But before we go out, let's do one last hack the planet, everybody.
Hack the planet! Hack the planet!
All right, so everybody, see you next time.